Today we're going to talk about quadratic word problems and how to take quadratic equations that are in vertex form and change them to standard form. In this graph, we're going to focus from the y-intercept to the vertex and down to the positive x-intercept. I'm going to go ahead and identify these 3 points. The y-intercept occurs at 0, 3. The vertex is at 2.5, 6, and the positive x-intercept is at 6, 0. When you're reading through a word problem, always look for information that would be important to you, like the fact that y represents the height, and the label that you'll put on these answers is feet. X represents time, and its label is seconds. In the first question, they ask, when will the ball hit the ground? When would be time, which means we're going to focus on the x value of the point where the ball hits the ground, 6, 0. So 6 will be my answer. And what label goes on when? Seconds. In the second question, it says, what was the ball's maximum height? Anytime a word problem uses the words maximum or minimum, they're referring to the vertex. And so that's where we're going to look for our answer. Since they're asking us about the height, and we know y represents the height, then we'll focus on the y value at the vertex. So the maximum height is 6 feet. In C, it asks when. When was the ball at this maximum height? So again, because they're asking us about the maximum, we're going to look at the vertex. But this time we're going to focus on the x value. When was it at this maximum height? At 2.5 seconds. How long was the ball in the air? This question is redundant. It's almost the same thing as when the ball will hit the ground. One of the reasons this question is here is to remind you that you're only going to focus on values from 0 and forward. We're not going to count the time that is in the negative. So the ball at 0 started into the air and landed on the ground at 6 seconds. How high off the ground was the ball when it was kicked? This is where we will focus on the y-intercept. The height of the ball at that point was 3 feet. In this next example, we're going to graph the equation in our graphing calculator, and we're going to look to the table of values to find our answer. A football team needs one more field goal to win the game. The goalpost that the ball must clear is 10 feet, or approximately 3.3 yards off of the ground. The path of the football after it is kicked for a 35-yard field goal is given by the equation y minus 11 equals negative 0.0125 times x minus 20 squared. Does the team win? Well, let's pull out our graphing calculator and put this equation into it. Before we do that, let's make sure that we convert the equation to the proper form to put in the calculator. What do we need to move? The negative 11. So we'll add 11 to both sides. When we put the equation into our calculator, it's going to look like this. Make sure that when you put a negative into your calculator, use the negative at the bottom of your calculator, the one in parentheses. And then any minus signs that come in the rest of the equation, we'll use the minus sign on the right side of our calculator. Let's go ahead and graph. In order to get a table so that you can see both your graph and the table at the same time, you'll go to Mode, you'll go about halfway down the screen and select Graph Table. On some of your calculators, it'll just say GT. Now, since they want us to look at the path of the football after it is kicked for a 35-yard field goal, we're going to focus on what is the height of this football at 35 yards. In order to do that, we will use the table of values. 35 yards is going to be an x value. If you cannot see these numbers on your table, you may need to adjust your table by selecting Second Graph. This will allow you to move your cursor up and down the table until you can find the value 35. At 35, my ball was 8.1875 yards in the air. Is that high enough to clear the field goal? It is. So, does the team win? Yes, they do. In number 3, I wanted to give you an example of a time where you might rather use the equation for the axis of symmetry to help you find the vertex instead of pulling out your calculator. In this one, the profit in thousands of dollars of a company is given by the equation P of x equals 5,000 plus 1,000x minus 5x squared, where x is the amount in thousands of dollars that the company spends on advertising. Use the axis of symmetry equation to find the x of the vertex. One of the reasons we would do this is because the numbers are so large. If we graph this in our graphing calculator, we're going to have to adjust our window or zoom out quite a bit to be able to see the graph and to find the vertex. Question number 8 asks, find the amount that the company has to spend to maximize its profits. So which value represents the amount they spend? If you look back in the problem, it says x is the amount in thousands of dollars that the company spends. So this first question is asking us for x, and we can find that simply by using our axis of symmetry. The first thing we need to do is rewrite our equation so that it is in the correct form, meaning that negative 5x squared should be written first, then a positive 1,000x, and finally plus 5,000. My axis of symmetry is x equals negative b divided by 2 times a. So I have negative 1,000 divided by negative 10, which gives me 100. Now you have to be careful. Before you write down a 100 as your answer, it does say that this amount spent is in thousands of dollars. So you do need to multiply by 1,000 so you can see how much they have to spend to maximize their profits. To find the maximum profit, that location will be the y of the vertex. Since we already have the x value, we can take this and plug it into the equation to find y. If you want to use your calculator to do this, you may. Make sure that you use parentheses everywhere you are plugging in a number. Now that you've plugged your equation in and hit enter, you get 55,000. But don't forget, when we write our final answer, it's in thousands of dollars. So if you multiply by 1,000, you're now going to get 55 million. In this final example, we're going to use an equation to find the height to which we can throw a grappling hook. It says you and your friends are hiking in a mountain. You want to climb to a ledge that is 20 feet above you. The height of the grappling hook you throw is given by this function. What is the maximum height the grappling hook can reach? So we really need to only find one value, the maximum height. Maximum tells me it's going to be at the vertex, and height tells me I'm going to want the y value of the vertex. So when you graph this in your calculator, like I've said before, be careful to use the appropriate buttons. Use the negative at the bottom of the calculator for the -16, and use the minus sign in front of the 32. When you graph it, we're going to look at our table to see if we can find where the vertex is. I can't see the vertex, but I can approximate its location by focusing on what that x value might be. I think the vertex is probably occurring at x equals -1. To use my table of values, I'm going to select second graph, and I'll move up this table until I can see -1. Now, one of the things that you want to focus on if you're only looking at your table of values to find your vertex, look for the pattern. You should notice that there are pairs on each side of the vertex, 5 and 5, 43, 43, -123, -123. So we've got these pairs over and over. The only thing in the dead center that does not have a pair is the vertex, -121. Now remember, we're only looking for the y value of the vertex, 21. So in this case, the maximum height that our grappling hook can reach is 21 feet. Will we be able to reach the ledge? Yes. All right, so now we're going to talk about how to take a quadratic function and change it from vertex form to standard form. We're basically just going to be expanding this equation. We want to get rid of any parentheses so that our standard form equation looks like this: ax squared plus bx plus c. So if you see a parentheses squared, you need to write that parentheses down 2 times. In order to solve this part of the problem, we can use the FOIL method, or you might choose to use boxes. In FOIL, we do double distribution. We take the first term and multiply it times both terms in the second parentheses, and we get x squared plus 3x. Now we'll go back and take the second term and do the same thing. That gives us 3x plus 9. And now we can write down this plus 1. Now that we got rid of all of our parentheses, we can combine the like terms. So our final answer is f of x is equal to x squared plus 6x plus 10. In the next example, you'll notice that there is a number in front of our parentheses squared. The process is similar, but we are going to keep the parentheses around our answer when we multiply the 2 parentheses together. We'll start off by multiplying x minus 4 times x minus 4. And like I just said, we will keep a parentheses around this answer. We get x squared minus 4x plus 16. Now I need to clean up what is on the inside of the parentheses. I can combine the 2 x terms together. That gives me x squared minus 8x plus 16, and then I have my plus 4. I cannot combine these constants because one is inside the parentheses and one is outside. I must start by distributing this -2 so that I can free up what's in the parentheses. This gives me -2x squared plus 16x minus 32 plus 4. Final step is to combine our constants, and then we'll be done. So f of x is equal to negative 2x squared plus 16x minus 28. In this final example, we have a fraction at the front. The process will be very similar to the last example. We'll start by writing down our parentheses 2 times. When we multiply these two parentheses together, we will keep the parentheses around the answer because we have this negative 1/3 in front. When I multiply these, I get x squared minus 3x and minus 3x combines to give me negative 6x plus 9. I will distribute my negative 1/3 to each term inside the parentheses. Be very careful with your sign, and if you need to use your calculator to multiply your fractions, that's okay too. I get negative 1/3 x squared plus 2x minus 3. And now I can bring down that negative 3 constant also. Combine your constants. Negative 1/3 x squared plus 2x minus 6.